Hey everybody, welcome back to the channel. If you haven't had a chance, please subscribe, like this video, turn on notifications. Today we are going to talk about preliminary analysis, and we're going to look at it in terms of categorical data. So let's get started. The agenda for what we're going to talk about, we're going to talk about processes versus populations, how they differ. We're going to talk about different types of data. Then I'm going to get into some numerical summaries for categorical data, and then finally we'll talk about some graphical summaries. A population is considered the collection of all objects of interest. Some examples of populations of interest are given in the slide. Populations are usually considered static. Usually we are unable to assess the entire population because it is unavailable in its entirety, or it is too expensive to get the required information from the entire population. Now, how does this compare to a process? A process is a series of steps that usually produce some sort of output. This is different from a population. The process is usually ongoing and not static. So we would consider a process something that runs over time. This means that we will never be able to assess the entire population because we will never have access to it within a process. So what are we going to do? Well, we're going to do something that we call sampling. So what's sampling? Well, a sample is just a subset of the population. The idea behind sampling is that we would like to summarize a population based on some characteristic of interest. In theory, we would like to measure this particular characteristic on each object in the population. But as we saw earlier, usually this is not possible. At this point, we will take a sample of objects from the population and measure the characteristic on the sample. So if you think about it, a sample really acts like a smaller version of the population. If you take a sample that is truly representative of the population, then it ends up being a smaller version of it. The sample should be large enough so that when we draw conclusions from the sample, these conclusions can be used to represent not just the sample, but the population as well. We also need to remember that the reason why we didn't measure the entire population was based on cost. So we don't want the sample to be too large, but we also want it to be large enough that it is representative of the population. We do have statistical techniques to calculate just how big a sample should be to meet a certain criteria. Now, sampling from a process is a little bit different. Remember that a process is not static, so we need to take into account the time that we sample and make the measurements. Usually for this reason, we try to sample multiple objects in certain time periods throughout the process. How we decide on how many and when to sample is established again through certain statistical techniques. Now let's talk a little bit about some different types of data. Data comes in many types. The type of data that you have collected will dictate what type of analysis is needed. We will classify data based on its coarseness and its scale. Let's first talk about scales of data. There are 4 different scales of data. We will discuss nominal, ordinal, interval, and ratio. Nominal or attribute data are such that the categories have no natural ordering to them. Some examples of this are given in the slide. Notice for each of the examples, there is no natural ordering to the categories. If there were natural ordering to the categories, then we would consider this ordinal data. Some examples of this kind of data can be found on the slide. Notice that although these variables have a natural ordering, they are still based on categories. A variable has an interval scale if the values can be ordered and the difference between 2 values makes sense. So this would eliminate the ordered categorical variables. A ratio scale is similar to an interval scale, except not only does the difference make sense, but also the ratio makes sense. Examples of both interval and ratio scaled variables are given in the slide. The other way to identify data is by its coarseness. The two types of coarseness for data are discrete and continuous. A discrete variable is one that can only take on whole numbers or at least can be coded to. This includes all categorical variables. It also includes any sort of count data. Some examples of discrete variables are given in the slide. Continuous variables are such that the value for the measurement can take on any value within a range. This, of course, is in theory since it is restricted by just how fine your measurement tool can discriminate. So in reality, nothing is truly continuous, but that is not an issue for the tools that we will use to analyze this type of data. You can see some examples of continuous data within the slide. Now let's talk a little bit about planning for an analysis. So now that you've collected data, what are we going to do with it? Well, of course, first, you should at least be thinking about visualizing the data using some sort of graphical technique, and then summarizing the data using some sort of numerical technique. We need to decide which tools to use to accomplish this. Let's first talk about some analysis techniques that we can use with discrete data. We will motivate this with an example. Assume that a company manufactures colored plastic balls. 100 balls are sampled from a lot to be put into a display case. The supervisor thinks that colors attract people, and he wants less than 50% of the balls sampled to be white. How can we summarize the data from the sample to determine the answer for this situation? The first thing that we could do is create a frequency table. The table can be created from nominal or ordinal data. This is a table of the counts and/or percentages of items that fall into each category. Here is the frequency table for the ball example. Notice we have a column for the category name, the actual count, and the percent of items that fall into that category. Based on this, it seems that 46% of the balls in the sample are white. If we can assume that this sample is representative of the entire population, then we should be able to assume that a little under half of the lot is made up of white balls. So far, we have looked at a numerical summary for categorical data. This was done with counts and percentages. Now we will view the summarized data through some graphs. The first graph we will look at will be a bar graph. A bar graph is a way to display counts or percentages in the form of a bar. Each bar represents a given category. The height of each bar represents the count or percentage of items in that category. Let's look at the bar graph for the balls data. You can see here that we have the count on the vertical axis, and each bar represents a different color ball. You should conclude from this by far that we are most likely to get a white ball followed by purple. The remaining colors have a much smaller chance of occurring. Now we can summarize this in a different way visually by looking at something called a pie chart. A pie chart has a similar function as a bar chart. We will create a pie, and the size of each piece will be based on the percentage in each category. Let's look at a pie chart for the balls data. We can see here that each pie piece is labeled with the color that it represents and the percentage that it makes up. You can see here that we get the same relationship as we saw with the bar graph. The majority of the colored balls drawn are either white or purple. Now let's draw conclusions. We can conclude here that 46% of the colors drawn were white. What answer would you give the supervisor? Would you expect to get less than 50% for each sample? We would expect it to change somewhat from sample to sample based on something called sampling variability. So your real-world answer should be that although in this particular case we would get 46%, we would be somewhat skeptical about the 50% conclusion. So now, how do we know moving forward what numerical and graphical summary to use for this type of data? Now, if I were forced to give my opinion, I would basically say do a frequency table of percentages for a numerical summary and a pie chart for a graphical summary. Now, remember, these summaries just describe the situation. You will need to interpret these things and then take action. Let's look at an example. To see the solutions for this particular example, please check out the video called Preliminary Analysis for Categorical Data Example in the description below.